Hello, this is Dr. Hanaa Assil, and this is about organic synthesis. So we're going to talk about use of chemical reactions to prepare certain compounds. So organic synthesis involves planning reaction schemes of up to 4 steps. This is for the Excel A2 chemistry, and techniques used in preparation and purification of the organic compounds. So let us start talking about how to prepare compounds. The one useful reagent that we're going to talk about is the Grignard reagent. And the Grignard reagent is used to increase the length of the carbon chain. So if I want to add one or more carbons to my compound, I use a Grignard reagent. How do we make the Grignard reagent? We make it from reaction of magnesium with an alkyl halide in ether. So this magnesium reacts with the alkyl halide to form what we call a Grignard reagent. So in this case, it's called, for example, ethyl magnesium halide. Okay, and then we use this Grignard reagent to react it with a wide range of compounds in order to prepare many different types of organic compounds. So let us take a look at this one by one. How do I use Grignard reagent? The Grignard reagent, if I want to prepare an alkane, I react it with water. So to prepare an alkane, the Grignard reagent reacts with water. When we react it with aldehydes, it will give either the primary or the secondary alcohol. So if I reacted with methanol, it gives the primary alcohol. If I react it with any other aldehyde, then it will give a secondary alcohol. Now, when we react it with ketones, then it gives a tertiary alcohol. So Grignard reagent with a ketone will give a tertiary alcohol. Are we following? Okay. What if I react it with something like carbon dioxide? Now, if I react Grignard reagent with carbon dioxide, what we get is carboxylic acid. So in order to prepare a carboxylic acid, I need to react the Grignard reagent with carbon dioxide. How does the Grignard reagent work? It works with nucleophilic addition. So the Grignard reagent, the carbon that is attached to the magnesium bromide or magnesium chloride, this carbon is a slightly negative carbon, so it acts as a nucleophile that attacks a carbonyl carbon. If it is reacting a ketone, we said it gives a tertiary alcohol. So the Grignard reagent reacts with nucleophilic addition. The carbon, slightly negative carbon, acts as a nucleophile that attacks the slightly positive carbonyl. In the end, in this case, it gives a tertiary alcohol. So let's take a look at this question. The question says the structure of 2-methyl propyl magnesium bromide is shown. Which statement best describes the circled carbon atom? We said this carbon atom that is attached to the magnesium bromide, it acts as a negative, slightly negative carbon, and the reaction is nucleophilic. Which compound reacts with 2-methyl propyl magnesium bromide to form 4-ethyl 2-methyl heptane for all? So he gives me the compound I'm trying to prepare using this Grignard reagent. So looking at it, you should realize that this is the new part that I am adding to the Grignard reagent. So it's as if I am removing the magnesium bromide and putting that chain instead of it. So how do I react it, or what do I react it with? I have to react it with this ketone in order to get that part added. So that ketone is hexane 3-one. Can you see how we think about it? Let's see the part we're adding, and then we put it as a ketone or an aldehyde if that's what it was. Benzaldehyde reacts with a Grignard reagent followed by hydrolysis to form this compound which we call 2-methyl-1-phenylbutane-1-ol. What is the formula of this Grignard reagent? Now he wants to know which one is the Grignard reagent. So if we look at it, this is the part that we have from the benzaldehyde. So the rest of it is the part that we get from the Grignard. So the rest of it with a magnesium bromide, that is my Grignard reagent. So which one is the correct answer? You can see that is the correct answer. Okay, let's go through a very quick review of the chemical reactions that many of the chemical reactions that we will need in order to prepare organic compounds in this syllabus. So let's take a look. For example, if I have a benzene ring, we talked about benzene ring, and we said if I want to add a halogen to the benzene ring, I react it with the halogen in presence of anhydrous FeBr3, or it could be chlorine in anhydrous FeCl3 as a catalyst. So that's one useful reaction we're going to use. Another reaction is if I want to put a methyl group on the benzene ring. How do I react it? Remember that to add a methyl group, this was what we call Friedel-Crafts alkylation. So we react it with methyl chloride in presence of aluminium chloride. What if we have the methyl benzene and I want to add a chlorine on the benzene ring? In that case, we react it again with chlorine in presence of aluminium chloride, like that first reaction. And remember that if I have a methyl group, then I put the incoming chlorine either on carbon number 2 or on carbon number 4. This is another useful reaction that we talked about, and we will need it to prepare organic compounds. How do I put a nitro group on the benzene ring? If I have a benzene ring, I need to react it with what? Concentrated nitric acid, concentrated sulfuric acid, then it puts an NO2 group on the benzene ring. So this is how we make nitrobenzene. Then if I want to change the nitrobenzene to an amine, phenylamine, I need to change the NO2 on the benzene ring. I need to make an amine, then I react it with tin in presence of concentrated HCl. Do you remember all of these reactions? So please remind yourselves of all these reactions. We're going to need it for the organic synthesis schemes. So if I have a methyl benzene and I want to oxidize the methyl group so that I get the acid. So to make benzoic acid, for example, I need to react the methyl benzene with alkaline potassium manganate or acidified potassium dichromate. What if I want to put a sulfonic group on the benzene ring? In that case, I react the benzene with what we call fuming sulfuric acid, which is sulfuric acid with sulfur trioxide. This will put the SO3H group on the benzene ring. What if I want to prepare a nitrile? Remember we said we may need a nitrile in order to add a new carbon to the chain. So from the halogenoalkane, I can react it with potassium cyanide in ethanol. This puts a nitrile group, a CN group, on the benzene ring, so I'm adding an extra carbon. What if I want to prepare an amine? We said, how do we prepare amines? We react the amine with a halogenoalkane. So a halogenoalkane in presence of ammonia in ethanol, this will replace the halogen with an amine group. Okay, what if we're trying to make phenylamine from chlorobenzene? So I have a chlorine on a benzene ring and I want to replace it with the amine group. We said we can react it with ammonia. This phenylamine, we can use it to make benzene diazonium chloride. And we said to change the NH2 to a diazonium chloride, we react it with sodium nitrite in HCl. And then this benzene diazonium chloride, I can react it with something like phenol in order to make an azo dye, which we said is a colored dye, orange or yellow. Reaction of amide. Remember we did amides and we said, okay, if I want the amide to become an amine, I can react it with lithium aluminium hydride. And this gives me the corresponding amine. If I react a secondary alcohol and I want to remove one of the carbons, this is how we remove a carbon from a chain. So if I'm starting with 2 carbons and or certain number of carbons and I want to remove a carbon, then I can react it with iodine in sodium hydroxide. So this is alkaline iodine solution. This reacts if we have a secondary alcohol so that we have the group CH3COH. Then the CH3 is removed and I end up with the sodium salt of the rest of the chain. Ethanol chloride. We said ethanol chloride is very useful. I can react it with ammonia if I want to make ethanamide, or I can react it with benzene if I want to add this group to the benzene ring. So this is phenylethanone. And we can use all of these reactions, and there are other reactions actually that we may be talking about, in order to devise reaction schemes for synthesis of organic compounds. So let's take examples of this. And in this syllabus, we need only up to 4 steps in order to prepare organic compounds, so we don't have very long reaction schemes. But let's take a look at shorter reaction schemes first. For example, if he says I am trying to prepare from benzene, I want to make phenylamine. Can you see how we think about it? He's saying I want to make phenylamine from benzene. How do we change benzene to phenylamine? We said actually we can do that directly, or we can change it into a nitro group first and then change it to an amine. What do we do to the benzene to put a nitro group on it? Concentrated nitric acid in presence of concentrated sulfuric acid. This will put a nitro group on the benzene, and then I can reduce this nitro group to form an amine. What do we do? Tin in presence of HCl will change the nitrobenzene into phenylamine. Let's try another one. In this case, we're trying to make benzene carboxylic acid from benzene carboxylic acid. This is actually benzoic acid, may be produced from benzene in a 2-step synthesis. So what should we do to change the benzene to benzoic acid or benzene carboxylic acid? Okay, let's try this. First, if I add methyl chloride in presence of aluminum chloride, what does that do? It adds a methyl group on the benzene ring. And then we said, what do we do to oxidize the methyl group on the benzene ring to acid? Well, this is alkaline potassium manganate will change the methyl group to the carboxylic acid group on the benzene ring. Again, if he says, I want to prepare this dicarboxylic acid from methylbenzene. So we're starting with methylbenzene and I want 2 carboxylic acids. So what can we do? We can first add another methyl on the benzene ring. So react it with methyl chloride in presence of aluminum chloride. This puts another methyl group on the benzene ring. And then we can oxidize this using alkaline potassium manganate. This will put 2 carboxylic groups on the benzene ring. I want you to note that for all of these schemes, or for most of these schemes, we can have more than one answer to the synthesis. We can synthesize these things in more than one scheme. So let's take a look at this example. This is trying to prepare 1-chloro-1-phenylethane from benzene. So he's saying 1-chloro-1-phenylethane is found in some fruits such as apples and is used to make fragrances. It can be synthesized from benzene in 3 steps. So what can we do? I want to put this side group on the benzene ring. So what do I start with? I can start with ethanoyl chloride in presence of anhydrous aluminium chloride. This will put this group on the benzene ring. Remember, reaction of benzene with ethanoyl chloride will add this group to the benzene ring. I want to change that to the chloro form. So what can I do? I can reduce the keto to an alcohol. So I put lithium aluminum hydride in presence of ether, and then we put change the OH to a chlorine. So this is reaction with phosphorus pentachloride, PCl5. This will exchange the OH with a Cl. Again, let's try this. He's saying devise a synthesis of compound F using salicylaldehyde, which he already gives me, and bromoethane as the only organic starting material. So he wants you to use this and bromoethane in order to get compound F. Include any other reagents, intermediate compounds, and essential reaction conditions. So what can we do? We have this starting compound and I want to add this group to it. Can you see how we think about it? What are we trying to add? We're trying to add that group to it. So what's the first thing I can do? I can use Grignard. So I can start with, he's saying I can start with bromoethane. So I use the bromoethane to make a Grignard reagent. Remember, reacting the halogenoalkane with magnesium in dry ether, reflux, these are the conditions. I add magnesium bromide to the halogenoalkane. So I prepared the Grignard reagent. Then I need to add that group. So I react this Grignard reagent with the salicylaldehyde. This gives me that group added on the benzene ring. Now I want to remove the OH and put a double bond. So this is actually dehydration. So that is concentrated phosphoric acid and heat. This gives me the product we're trying to make. Okay? This question says, devise a reaction scheme to produce benzoic acid from benzene via bromobenzene and then a Grignard reagent. So we want to start with benzene, change it to bromobenzene, make a Grignard reagent, and then get benzoic acid. Include the reagents, essential conditions, the name of the structure of name or structure of each of the intermediate compounds. So let's take a look. We're trying from benzene. So I can use benzene to make bromobenzene. benzene. So I'm adding, for example, bromine in presence of anhydrous FeBr3 as a catalyst. This puts a bromine on the benzene. Now I can use this to make a Grignard. We said to make a Grignard, we react it with what? Magnesium in dry ether. This gives me this Grignard reagent. Then I want to react it with what to give benzoic acid. We said if we react the Grignard with carbon dioxide, this gives a carboxylic acid on the benzene ring. Okay? Another question. Devise a reaction scheme to prepare. What are we trying to prepare? 2-methyl butene from butanone. 2-methyl butene from butanone. And he's saying using no more than 4 steps. Identify reagents, essential conditions, name or structure of the intermediate compound. So we're starting with butanone. What can we do to change it to methyl butene? Okay, let's start using, remember that we're going to add a methyl group to the butanone. The butanone is something that has 4 carbons. We want something that has 5 carbons, so that means I'm going to use a Grignard. Now, what am I adding? I'm adding that extra methyl group there. So I make a Grignard using methyl bromide, magnesium in dry ether. I get the Grignard reagent. Then I can react the Grignard reagent with the butanone. What will that do? That will add the extra methyl group on that carbon, but then I have it in the form of an alcohol. How do I change the alcohol into an alkene? Concentrated phosphoric acid will give the required product. Okay, sometimes he gives you the synthesis and asks you things about the synthesis. So let's take a look at this. He's giving me an incomplete synthesis for methyl red, starting from 2-nitrobenzaldehyde and phenylamine. So I have the 2 compounds that I can start with, 2-nitrobenzaldehyde and phenylamine, and in the end I want to get that compound at the bottom, methyl red. Okay, from the nitrobenzaldehyde, what can I do? I can change the benzaldehyde to acid. So he's telling me, this is something he gives me, he's changing the aldehyde first into acid. So what should we use? An oxidizing agent, of course, like acidified potassium dichromate, heat under reflux. This will give the acid instead of the aldehyde. Then he's going to add tin in presence of HCl. What does that do? Remember that tin in HCl will change what? It will change that NO2 group to NH2. So it changes the nitro to amino. Then he wants to change that amino group to a diazonium salt. What do we do to change an amine group to diazonium salt? React it with sodium nitrite plus HCl. So in that case, we got the diazonium salt. Now we want to react it with something to give the methyl red. So he got the phenylamine, he added excess methyl iodide and heat. What happens if I add an alkyl halide to an amine? It replaces the hydrogens on the nitrogen to methyl group. So he has excess. That means we're going to replace both hydrogens on the amine group with a methyl group. React these together, you end up with the compound that he's trying to make. Okay? Now, when we react them together, you have to know that this is in alkaline conditions, very low temperature. We said the diazonium salt needs a temperature less than 10 degrees Celsius or it will decompose. So This is the coupling reaction to give the methyl red. Another question. This was saying that he wants to make 2-ethanoyl aminobenzoic acid, and he wants to start with benzene. So what do we do to the benzene to end up with 2-ethanoyl aminobenzoic acid? First, I can put a methyl group on the benzene ring. What do we do to put the methyl group on the benzene ring? React with methyl chloride in presence of aluminum chloride. Then what? Look at the final product and see what we can do. The next step, we either oxidize the methyl group there or we add that other group at the bottom. So in order to add that group at the bottom, I can add a nitro group. Remember, to add the nitro group, we need concentrated nitric acid in concentrated sulfuric acid. Then oxidize the methyl. I can put alkaline potassium manganate. It oxidizes the methyl on the benzene ring to acid. Now I want to change this group to what? To an amino group. So I'm going to change the NO2 to NH2. This uses what? We use tin in concentrated HCl. And then what do I do to get that final product? I react this compound with ethanoyl chloride. This will give 2-ethanoyl aminobenzoic acid. Okay. This question says, devise a reaction scheme to prepare propane 1-ol from butanone. So we're trying to make propane 1-ol from butanone. Of course, this means I'm removing one of the carbons of the butanone. Okay, and he says using no more than 4 steps. So how do I change butanone to propane 1-ol? Well, the first thing I can do is remove the extra methyl group. Remember, we said if I have a methyl next to a ketone, I can add iodine in presence of sodium hydroxide, alkaline iodine solution. It removes that extra CH3 and puts a sodium salt instead of it. So this prepares sodium propanoate. Then what? I want to change that eventually to propane 1-ol. I can add acid in order to change the sodium salt to propanoic acid. And then how do I change propanoic acid to propane 1-ol? I just reduce lithium aluminum hydride in dry ether will give the required product. Again, let's try this. He's trying to devise a synthesis of this final compound, N-phenylethyl ethanamide, starting from bromomethylbenzene. And he's specifying without, please note the instructions, without the use of a Grignard reagent. So we're not going to use Grignard here. And I want to change bromomethylbenzene to that final compound. So what should we do? Well, let's see. First, I can change this into a nitrile group. Remember, this will help me to add an extra carbon on the chain. How do we do this? We react it with potassium cyanide in aqueous ethanol. You replace the Br with the cyanide or the nitrile group. Then what? Then we can reduce this lithium aluminum hydride in dry ether. This changes it to an amine with an extra carbon. So now we have added an extra carbon to the chain and we have an amine. Now how do we change it to that final compound? I can just react it with ethanoyl chloride. This will add the required chain to the amino group, and that gives me my product. Again, let's try this. He's trying to make azoviolet. Can you see azoviolet? And we want to start from nitrobenzene in 4 steps. So, nitrobenzene, look at what you're starting with and look at the final product and see what we're trying to add. Can you see the nitrobenzene? Obviously, we need to make a diazonium salt and then react it with that other one. So let us see what we should do. We add a chlorine on the benzene ring. So we react this with chlorine in presence of aluminum chloride. This gives me the chlorine on the carbon number 4 of the benzene ring. Then I can change this chlorine to an amine group. So I react it with ammonia. It replaces the chlorine on the benzene to an amine group. Then what? Then I can change that amine group into the diazonium salt. So we add sodium nitrite in HCl, or we're basically reacting with nitrous acid at low temperature, less than 10 degrees. This gives me the diazonium salt. How do I change this diazonium salt to my final product? I have to react it with this part of the compound. So that is the part we're adding. And of course, this coupling reaction is in presence of sodium hydroxide at 5 degrees Celsius. This gives me my final product. Another synthesis. He's trying to make something called Sudan 1, and he's saying it's an intense orange-red azo dye that is used in color waxes, oils, and polishes, and we need to prepare it from benzene. Can you see that? Okay, so what do we want to do? First, add a nitro group on the benzene ring, react with concentrated nitric, concentrated sulfuric, and heat. This puts the nitro group on the benzene ring. Then reduce that to the amine using tin in concentrated HCl. So this puts my amine group on the benzene ring. Then I need to make the diazonium salt. So I react it with sodium nitrite HCl at 5 degrees Celsius. This gives me the benzene diazonium chloride. Then what? And then I want to add that extra group to the diazonium salt. That means I'm reacting it with this, again in presence of sodium hydroxide, 5 degrees Celsius, and I get my product. Benzyl benzoate. Can you see what is benzyl benzoate? That's my final product down there. Is present in many asthma drugs. Outline how a chemist could synthesize a sample of benzyl benzoate in 3 or 4 steps using benzaldehyde as the only organic compound. Include reagents, conditions, and structures of the intermediates. Okay, so I'm starting with benzaldehyde, and I want to end up with that benzyl benzoate. So what's the first thing I can do? Well, I can oxidize the aldehyde to acid. Sulfuric acid and potassium dichromate will oxidize the aldehyde to acid. Then what? This benzaldehyde I can also use to make, remember that he's saying benzaldehyde is the only organic compound that I'm starting with. So I have to change this benzaldehyde to that other product that I'm trying to make. Lithium aluminium hydride in dry ether will change the aldehyde to alcohol. And then this benzoic acid reacted with the alcohol in presence of concentrate sulfuric acid. So this is basic esterification, will give me the benzyl benzoate. Are we okay with this? Another synthesis. He's saying mandelic acid to hydroxy to phenyl ethanoic acid. This is mandelic acid. And he's saying it has a long history of medical use as an antibiotic and component of face creams and so on. And he's saying mandelic acid can be synthesized from benzene. So we're going to start with benzene, make mandelic acid, and then there is another compound, this one, which he calls cyclandelate, will be synthesized from mandelic acid. So let's go through this. Starting from benzene, I want to make mandelic acid and then that final product. So what can I do? What did he add on the benzene ring to make the mandelic acid? Well, we can start with adding an aldehyde group. So adding an aldehyde group is methanoyl chloride in anhydrous aluminum chloride. That will add aldehyde to the benzene ring. And then what? And then I'm going to add, remember, I need to add extra carbon. So I need to react it with potassium cyanide in HCN. This will change the aldehyde to a nitrile group. So I'm adding an extra carbon here. Then what? In presence of acid, that will hydrolyze the nitrile group. So I get an acid with an extra carbon. So that is my mandelic acid. Then what? In order to get that final product, can you see what it is? This is just an ester in which you're adding that group to the acid. This will give you the ester that he wants. Of course, esterification is in presence of concentrated sulfuric acid, heat under reflux, we end up with the required ester. That's the end of this. I hope this was useful. Please go through all the reactions, practice drawing the schemes, and remember that you could come up with a different scheme from what I have. If it is correct, that's fine, no problem. Okay, thank you for listening.